Hello, this is for questions in Algebra 2 and Trigonometry. Let's look at a couple of questions together. So here we want to sketch this graph. Now, once we want to try to do that, what we want to do is we want to try to get the graphing calculator, and then set the y equals, I believe it was 5 over 3 to the x power. So, open parentheses, open parentheses, 5 over 3, close parentheses, and raise that by x. Now, once we have done that, we want to go for the tables. So second table. Let me try to set up the table a bit easier for us to look at. And then what we want to do is independent order. Alright, once again, second table, and that's what we end up getting. Just to be more inclusive on the negative numbers, I'm just going to put it in this way. So basically what would have happened is if you use these point values and then sketch, and then we're going to graph it, but let me set the window. Maybe we'll set the window as -3 to +3. Then graph. I'm going to go for zoom fit to have better reading on this one. So zoom fit. Zoom fit is right over here. That keeps the x value as they are and change the y value automatically for you. And I'm going to change the window to the x y value, y minimum. Let me call it as -1 so that we can see the x-axis. That'll be better. And then we're going to call this one y max as 5. Then we will actually have one nice graph. Now, in your case, what you can do is using the graph paper and plot a few of these points from here to here, and then just plot the points all together. Now, then when I'm looking at 2.2, what I'm looking at is this one. Let me change the color to red, maybe. So 2.2 seems to be around here. Going up here, and then coming back to the left. 2.2 then seems to be about 3, and 2.9 seems to be around 4.5. So estimate the values. I mean, this is truly based upon a graph. Then what we'll get to realize is that this one seems to be about 3, and this one seems to be about 4.5 or 4.4. How about that? So I'm just going to call this one as 3, 0. Then what we can say is when x equals 2.2, y is approximately 3 comma 0, and when x equals 2.9, y is approximately 4.4. Now we can check this one by graphing calculators just to make sure. So then one of the way which we can check it is, second, trace, get to the calculation, and then value. Then what we can do is we can actually input the value 2.2. Then it was about 3.07. So in fact, it would have been better if I were to write 3.1, I guess, in real calculation. So you know what? I'm going to change that. And I call this one as 3.1. I know that it's not quite nice, but if you had to be purely based upon graphical, it wouldn't matter either way, but since we have the calculator, we're trying to be a bit more precise. And second, once again, second, calc, and then trying to find the value. X equals 2.9. That seems to be about right, 4.4-ish. All right, so that was okay. All right, now let us move on to the second portion. Make the table for e to the x from -2 to 3, and then plotting those points, and estimate the curve e to the 1/2. All right, so what we want to do is y equals, now has to be e to the x power. Simply x over there. Now, we want to get the window, actually table, second, table. All right, so we can bring this one down. But -2 to 3, so we're looking at the values from here to here. And using that, also, we're going to set the window as -2 to 3. And we're going to ask zoom fit, which is simply press 0. Then you will get that kind of curve. But going back to the window, we'll try to write this one up a bit nicely by showing -1 and then 21, because those are the values right before and right after. And press enter and graph. All right, so in your case, you can try to do this one by plotting these points on the graph paper. Now, so once again, when x equals 1/2, seems to be around here, and corresponding value seems to be a bit less than 1. So, oh, actually, 1 is, I'm sorry, 1 is around here, so a bit less than 2. So we'll say about e to the 1/2 is about, I'd say, 1.8. and we'll try to calculate that. So here we have, oops, second, and then 0.5. Ah, 1.648. So my approximation was a bit off, but either way is okay. In this case, we're looking at graph alone. Now here, second part of the questions will be something like this. In order for us to find the x value by itself, then what we can do is simply raise each side by the reciprocal of the exponent, which is 3. Then we get to realize that x must be equal to 64. Now, all you have to do to check, or you have to plug in 64 in place of x, then you will get that value. Here, we have to raise this one by 5 over 2. 5 over 2. Now, to illustrate that, we get to realize over 2 is the square root of 9 to the 5th power. That's another way of looking at it. Then this becomes 3 to the 5th power. Now we can just leave the answer as 3 to the 5th power, or if you wanted to actually calculate this one, and this becomes 243. Same as this one here, raising it by negative 1/2. Negative 1/2. And here we get to realize the negative gets us 1 over square root of 9, which is equal to 1 over 3. Alright, next we can multiply each side by 2, or cross multiply, so we get 2 y to the negative 1 is equal to 24. And then dividing each side by 2, so we get y to the negative 1 is equal to 12. Or we could have actually canceled out 2's from the beginning, it doesn't matter. And to have the y by itself, we have to raise this one up to negative 1 power, which is simply the reciprocal, by the way. Then y must be equal to 1 over 12. Here we have subtracting 14 from each side. Negative 4b to the 1/3 power is equal to negative 12. Dividing each side by negative 4, so b to the 1/3 power will be equal to 3. Raising each side by third power, then we get to realize that b must be equal to 27. Once again, to check the answers, just simply plug in those values back into the variables. Alright, so to the nearest hundredth. So once again, in order for us to do this one, raising each one to the negative 1/3 power. Negative 1/3 power. Simply then x equals 1 over cube root of 27. So to calculate that, so here 1 over cube root. I'm going to put down to 24 to the 1/3 power. Then we get to realize that it was 0.346. So using that, I'll say the answer is approximately be 5, nearest hundredth. Here we end up getting, raising this one to the 3 over 2 power. So going for this one once again, 6 to the 6 to the, open parentheses, 3 over 2 power, close parentheses. I believe that's what we're looking at. Okay. Press enter. Now then here, be careful. It looks like 14.7, but nearest hundredth, then what we need to do is this. Here y is equal to 14.70. We need to put down 0 at the end to show that it was nearest hundredth. Alright? Here we're going to have dividing each side by 2, subtracting it by 2, so we get 3z to the third power is equal to 25, and then z to the third power will be equal to 25 over 3. So therefore z, there must be cube root of 25 over 3. Now, if you want to go for the cube root, one way which you can do is do the math. (25) over 3. So here we have 2.03 is the nearest hundredth. Alright, now let's go for the next one here. In this case, we have to have the same basis, basically, which is equal to 2 to the 4th power. That's what 16 is. So we get to realize the x must be equal to 4. Here, same base already, and x plus 1 must be equal to 2x plus 3. Then by subtracting 1, we get x equals 2x plus 2. Then when you ultimately solve it, we get to realize the x must be equal to -2. Now here, we need to make the first expression. So 5 squared working to the x power is equal to 5 the x plus 3 power. And having the exponents the same, then we get to have 2x must be equal to x plus 3. By subtracting x, we get x equals 3. Here 125 is in fact 5 to the third power. X minus 1 over here. And this becomes 5 squared the x power. So then here we have 3x minus 3 is equal to 2x. Then by subtracting 3x from each side, we get to have x equals ultimately 3. Here we have 3 to the -1 to the x power is equal to 3 squared the 1 minus x power. That means here we have -x must be equal to 2 minus 2x. Then we get to realize that x must be equal to 2. And checking it, we can plug in all these x values back onto the in places of x. Alright, the next. Here, both of them, in fact, 0.25 is 1 over 4. So one way for us to write this one is this: 4 to the -1 power, and x minus 2, which is equal to 4 to the x power. That means here we have negative x plus 2. So then here must be equal to 4. Then here when you solve this one, we get to realize that x must be equal to negative 2. Now let's try looking into this one. 0.04 in fact is equal to 1 over 25. So if you have to rewrite this one, we get 5 to the x minus 1 is in fact equal to 5 to the negative 2 power the 2x. Then we have x minus 1 must be equal to negative 4x. So once you do this one, you will realize that x must be equal to 1/5. Alright, let's move on to the next. Here, so we have a trust fund, $2.5 million was donated, and once each year, the organization spends 2% of the values of the funds, that the fund decreases by 2%. What will be the value of the fund after 25 years? So then basically this is the exponential growth or exponential decay question. So here, the value becomes final amount is the principal times 1 plus or minus, depending upon if it's increase or decrease, of r to the t power. Now, this is when there's annual compound, meaning it happens once a year. Then here what's going to be happening is this, 2.5 million. I'm going to keep the unit as a million, and then 1 minus 0.02. That's a 2% decrease. And then year is 25, so that's basically what we have to do. Put that into our calculator. So we have 2.5, open parenthesis, 1 minus 0.02, and raise that by 20 fifth power. Oops. Raise that by 25th power. Alright. And as you can see from here, our answer now becomes about 1.5 million. Alright, the next question. Here the number of wolves increase 3% per year. So by the same way as before, how many were present in 10 years ago? Now, if you have to think about this one, 10 years ago would have been the negative value. So final amount, same way, is 5,400 times 1 plus 0.03, that's the 3%. But we were looking at how many were present 10 years ago, so we could put it as subtracting 10. Now, then let us try to look through this one together. Clear. In this one, so we have 5,400 times 1 plus 0.03, but we need to raise this one to negative 10. Then on this manner, we will be realizing that our answer would have been approximately 4,018 4,018 words, I guess. All right. Here, write an equation of its inverse function and sketch the graph. Now, inverse function is simply when you switch x and y. That's one way for you to look at. Then here, instead of y equals, we could say x equals 3 to the y power. But in order for you to leave the y by itself, then we're gonna try to express this one as y equals log base 3 of x. Now, but in order for you to put this one into the calculator to sketch, what would have been happening is this. This is the same as log of x over log of 3. Now, the property of log base 8 of the b is equal to simply log of b, common logarithm of log of 8. That using this principle, we can put that in to the calculator, and you should be able to sketch it. Then you should be able to observe the symmetry about y equals x. Now, once again, logarithmic form, then here we get to see 2 equals log base 8 of 64. Same as this one. Here we get to realize negative 2 equals log, what's the base? Base is 4. Now what's the result that we end up getting? Which is 0.0625. Alright. The next one, exponential form. Here we get to have base is 10, exponent is 2, is equal to 100. Here 7 to the 0 power is equal to 1. Here 49 to the 3 over 2 power is equal to 343. Evaluate each one. So here we have 4 log base 6. So I'm going to try to look into 216 in terms of 6. So we get to realize that 216 is 6 to the 3rd power. Then by the power rule, we get to realize that 3 comes out, so it becomes 12 log base 6 of 6. But when you have base and then the result of 3 equal to each other, that's equal to 1. So the answer becomes simply 12. Here, once again, this is equal to log base of 3. Now, then here, 729, I believe that it is 3 to the 6th power. Then this becomes 6 log base 3 of 3, which will be simply equal to 6. Here we have log base 2 of 2 to the 4th power. That's because 2 to the 4th power is equal to 16, and here once again we get to have 4 coming out, log base of 2, which is equal to 4 by itself. Alright. Use the table on the right. Okay. Evaluate each expression. Now this is base of 3. Now then simply this, if I were to call this one in 2, for example, if I were to rewrite this one is equal to 2 to the okay, if I want to rewrite this one as logarithm, then why don't I call this one as k? And here, log base 3 of 27 times 81 will be equal to log base 3 of 27 plus log base 3 of 81. But just like what we have done earlier, this is equal to log of base 3 of 27 is 3, so what I can write this must be equal to 3. I'm looking right over here. And then this must be equal to 4. So plus 4 is equal to 7. That means this must be equal to log base 3 of something must be equal to 7. And that something is equal to k. But when I see that 7 comes from right over here, so the value inside must be 2187. That must be equal to k. Alright, let us move on to the next one. A single logarithm and then find the value of each expression. Here whenever you add, you gotta multiply the values inside. So we have 9 times 1 simply is equal to 9. This is equal to 2. Here we have, same as earlier, if you look at the previous question, number, from the previous slide, then this must be equal to 7. Single logarithm, and then here we have log base e of 10x. By multiplication, here we have log base 2 of ab. Expanding this one, so whenever you multiply, you gotta add. So log base 2 of 2 plus log base 2 of a plus log base 2 of b. But we realize that this one is equal to 1, so it simply equals to 1 plus log base 2 of a plus log base 2 of b. Alright. Here we have this one is equal to log base 2 of x plus log base 2 of y. Now the base 2 of x is equal to a, and the other one is b, so this simply becomes a plus b. Alright, that's it. Have a nice day.